We've talked about the residuals and a little bit about the residual plot throughout our lessons this week, but I just want to make sure we understand everything we need to know about residuals. And so let's go back to when we predicted with our least squared regression line. We did this example earlier where we predicted the fat content of a Tender Crisp sandwich to be 36.6 grams of fat. And in actuality, it only has 22 grams of fat, which means if I'm looking at the 31 down here, the 26, it's probably this guy. This is probably my point. Now keep in mind then that what I have is I have a negative residual because the actual value is below the predicted value. And to find the value of that residual, I would take my predicted value, or excuse me, my observed value, so the actual value of 22. I would subtract my predicted value, which is what I found up here, and that gives me my negative residual of negative 14.6. What does that tell me? That tells me that the sandwich, the Tender Crisp sandwich, has about 14.6 fewer grams of fat than my model predicts. So in addition to being able to calculate the individual residuals, we can also look at the residuals in a whole graphical form, which means we're going to look for patterns in the residuals. I talked to you a little bit about this when we created that residual plot in StatCrunch. But remember, what we're looking for is to determine if a linear regression equation is appropriate. So again, looking at this, we have a scatter plot of emperor penguins. So we have the duration in minutes of a dive, as well as the heart rate of their dive. And it has a negative correlation coefficient, or a negative R, of negative 0.8456. That's a pretty solid number, but still I'm looking at this data and it kind of has a curve to it that I'm concerned about. So instead of just going straight to using that linear model, I would look at the residuals. Remember, what we're looking for in a residual plot is absolutely nothing. No direction, no shape, no bends, no patterns, no outliers. We just want a bunch of random scatter that doesn't make any sense at all, and that's perfect for a residual plot. If I start seeing patterns or bends or shapes, then I know I've got a problem. So here is my residual plot for my penguin data, and what is very concerning about this is that it appears to narrow at the end. So not only did I have a scatter plot that kind of concerned me, but now I have a residual plot that really concerns me. So because of this, I would not use a linear model. Just as we did with the Tender Crisp sandwich, which was just using one value, I can also look at a group of values. So looking at this residual plot, I've got a group of values, or excuse me, a group of, in this case, cereals that have a high residual, which means their fat content, or their calories, excuse me, are much higher than what my model predicts. So why is that important? Well, it might be good for us to look at what kind of cereals are those, and I can see that most of these include fruits and nuts, and hopefully we all know that nuts, while they're great for you and have a lot of protein, also have a lot of fat, and fat is calories. So it's important to be able to pick those things out of the group. I would also be looking at these values where they were much lower than normal. Why are those so much lower? And again, it's okay to separate those out and examine them separately.